Now that we've gone through and built this microservice, let's walk through the steps and individually look at the components. So step one, we have a CloudWatch event. And really this is a key aspect of building a microservice is when do you actually schedule this microservice to run if it's a data collection job. We had a 1 minute interval, which in our case for development is a great interval to test because immediately we can look at the payloads, we can see what's happening in our data engineering pipeline. So this is really a good knob to turn off and on depending on where you're at. In a production data engineering pipeline, most likely you wouldn't leave it at a minute. You more likely would move it to an hour or to, let's say, a day, and you would schedule that CloudWatch event. Now, next, when that CloudWatch event is triggered over to the Lambda is then going to do the hard work of collecting the initial data as the producer function. So what this does is it grabs information from DynamoDB, names of companies. In this case, it was Google, Facebook, Microsoft, and each one of those companies as an entity gets put into Amazon SQS. Now, SQS is a really fascinating part of a serverless pipeline. And what's fascinating about it is that it can handle infinite scale. And what that means is that if there's a one-to-one relationship here, where every time a message comes in, one message goes into SQS and one Lambda call is actually executed. Well, this is a highly concurrent parallel pipeline that allows us to use something that has infinite scale. And that's really the power of serverless, is that the functions themselves don't actually do all the heavy lifting. It's the infrastructure that you're using that allows you to do that heavy lifting. Now next, what happens, in this again is the producer, is we go to the consumer side. And the consumer side, what we do is we call out into the AI API. In our case, we're using AWS Comprehend, but it could be recognition, it could be translate, it could be some other pre-built API. And that Lambda function is triggered also asynchronously, and this is also a one-to-one. So what's powerful about this event-based Lambda execution pipeline is that if you have 1,000 messages in SQS, 1,000 Lambdas will run concurrently. And again, if you had to build this yourself without the serverless technology, having that level of parallelism would be really difficult to obtain. So in a nutshell, by leveraging SQS as the heart and soul of our data pipeline, it allows our Lambda function to have incredible parallelization. Finally, the last phase here is this artifact. So if we go to this S3 artifact, this consumer pipeline here is able to actually put that final artifact into S3, and that's actually the end of our chain. Now, if there was another serverless pipeline that needed to operate on that S3 file, we could have a second version of this. So we could then have another Lambda function that listens to an S3 event. That S3 event could be resizing an image or doing additional processing on it. So that's really the other power of serverless, is that by breaking each of these components step by step into pieces, the reasonably complex application that you're building is easy to debug or replace pieces when you're building a second system. And really, in a nutshell, that's really the power of serverless, is you build these small things, you connect them together, and also you build these event-driven architectures, which are cloud native, versus pole-based architectures, which are really a pre-cloud type of architecture. So let's go ahead and remember, when you're building your serverless applications, that you want to break each component down into its own distinct function. And then once you do that, you can rebuild applications very quickly by using these patterns that you've learned.